So in this session I'll be solving sums you sent me to solve. Those sums may be from your textbooks, NCERT, exemplar or any book, and this session will be on indefinite integration. Okay? Some of you might not have any doubt, but just try to do the sums I am solving here, which is required for your board examinations. School based examinations are there, then board examinations are there. I am starting with NCERT miscellaneous. You can send your problem in WhatsApp or in the description box. Let me start with miscellaneous exercise on chapter 7 with this sum. The book I have here, it is number 4, dx by x square into x4 plus 1 to the power 3 by 4. Okay, looks very difficult, but not a difficult sum at all. You just from the bracket you take x to the power 4 common. If you take x to the power 4 common, it is 1 plus 1 by x to the power 4. This whole thing to the power 3 by 4. So this is not the only sum. Many sums can be chosen like this, can be made like this by us. To give you trouble, we change the sum a bit and then set it in exam. Okay, but technique will remain the same. Whenever this kind of thing is there, you take common from bracket and then make a substitution. Put 1 plus 1 by x to the power 4 equal to z. So differentiating both sides, minus 4 x to the power minus 5 dx equal to dz. So you can see that one part of the integration has come here, minus 1 by 4 dz. You just substitute there, it is minus 1 by 4 dz. So this I going to be what now? Integrand I equal to minus 1 by 4 dz by z to the power 3 by 4. This will be z to the power minus 3 by 4 plus 1 by this plus c. So 1 by 4 minus z to the power 1 by 4 plus c. This is minus to the power 1 by 4 plus c. Clear? This is the answer to the question. You just check it once more. Now we can approach. See, common sums, there is no need to do it with me here. Some uncommon problems we are going to solve, and you will get enough time to think before I do it here. Just later, I think this one going to be little bit uncommon for you. That is NCERT miscellaneous exercise number 11. The book I have, it's not new one. You can find the sum in your book. X plus a cos x plus b. You just think, you will get 1 minute time and then I will start. So how to do this? This one, not only the one sum, inside the main exercise they have given the sum taking sin x plus a, sin x plus b. So here this is just a trigonometric manipulation. We multiply nr and dr by this quantity, so that I am writing this as sin x plus a minus x plus b. Why? So when you expand and separate, then we get tan form. Okay, this is cos x plus a cos x plus b, 1 by sin a minus b outside. Clear? Keep 1 by sin a minus b outside and try to understand the advantage here. It is sin a minus b, that is sin a cos b minus cos a sin b. It's all right. That divide by cos x plus a into cos x plus b. Now separate. If you separate, you can see that cos x plus b get cancelled from the first term, and from second term cos x plus a get cancelled. And this division is allowed because sin a minus b is a constant. Now separate. So you will be getting sin by cos tan x plus a dx minus this by this tan x plus b dx. Okay, tan x formula all of you know, log sec x, sin a minus b log of mod of sec x plus a log of mod of sec x plus b plus c. Hope you have understood. And now you don't have any problem if the sum given in terms of sin x plus a into sin x plus b. Use the same method, multiply and divide. Maybe sin a minus b, maybe cos a minus b, that you have to decide instantly. Let us go for next one. This sum I did not want to tell you, but as my observation goes on, students take huge many steps to solve this problem. I have to say something about this kind of sum. I can use this one ax plus b by x square plus 1, cx plus d by x square plus 4, but I will not do, because x square is a common factor and the denominator difference between these two factors is 3. So with this observation, I will be remembering one simple partial fraction. You write 1 by b minus 1 by a. Outside you take a minus b common. Like you used to do, no? In junior classes also, 1 by 15, 3 into 5. How can you write this? 1 by 5 minus 3. Then 1 by 3 minus 1 by 5. So half into 1/3 minus 1 by 5. So this thing, if we imagine that x square plus 1 is a and x square plus 4 is b, then 1 by b minus a. 4 minus 1 you take outside because it is constant, and here you write numerator as x square plus 4. No need to take the trouble of splitting this one as ax plus b and cx plus d form. This we can do always. And you are in class 12, you understand the manipulation with me, manipulation with this sum. So it is 1 by 3, separate now, it will be dx by x square plus 1 dx by x square plus 4. So 1/3 tan inverse x minus half tan inverse x by 2. You could have done yourself, but I am using my views to solve this sum. Okay, how to simplify, how to reduce number of steps, that I want to discuss mainly here. You might have done all sums on your own. Another problem, normally as my experience goes on, students of pure mathematics, I mean mathematics, they suffer. I just wish to remind you, this e to the power, I told you earlier also, no base is given means e base is there. It will be simply e to the power log a to the power b. Answer is a to the power b, isn't it? So whenever sum arise this form, e to the power 3 log x multiplied by this to the power minus 1, NCERT miscellaneous. So it is x cube by x4 plus 1. You must remember this simple trick. Now the sum can be solved easily if you put x to the power 4 plus 1 equal to z, 4x cube dx equal to dz. So x cube dx equal to 1/4 dz. So I going to be what? 1/4 dz by z, 1/4 outside, log of mod z. So this will be 1/4 log of mod of this plus c. Clear? Understood? Another very common sum I'd like to discuss with you, that is sum number 18 from NCERT miscellaneous, that is dx by under root sin cube x sin x plus alpha. This sum also can be given in various forms. This is just one type shown here. Okay, hope you are practicing with me. This one, reduction can be done this way. You can send your problem in WhatsApp, whatever integration problem, indefinite integration this class. Don't send definite, I will not solve it today. Indefinite, whatever doubt you have, you can send me in WhatsApp. So sin x plus alpha cos x sin alpha, if we expand it this manner. Okay, now you will be taking, this is just practice once with me, next time you will be able to do it yourself. If you take sin x common from here within bracket, then you are getting cos alpha plus what? Divide by sin x, sin alpha cot x, isn't it? Do you see something over there? If you take sin to the power 4 common here, there it will be under root sin to the power 4x cos alpha plus sin alpha into cot x. This sin to the power 4, if you take outside, then it will be 1 by sin square x, this multiplied by dx by under root cos alpha sin alpha into cot x. So there will be cosec square x into dx by as derivative of cot x only will be involved if you assume something. So the only substitution cos alpha plus sin alpha cot x equal to z square helps. You put this thing cos alpha plus sin alpha into cot x equal to z square. This will be 0. Cot x value is what? Minus cosec square dx to z dz. So I equal to, you need only cosec square x part, isn't it? So value of cosec square x you have to find after substitution. Sorry. Yeah, from here you find, from this one you find cosec square x dx. This will be minus 2z dz by sin alpha. So I will be what? Cosec square x dx you got, substitute, minus 2z dz by sin alpha, and this thing you have taken z square, so put z over there. So it will be minus 2 by sin alpha integration z minus 2 cosec alpha into dz integration z this plus c. So minus 2 cosec alpha into z is under root cos alpha plus sin alpha cot x this plus c. Clear? Understood? How to solve the 19th one? X belongs to 0, 1. So root x also belongs to 0, 1. Square root is a positive quantity. So this implies root x belongs to 0, 1. Your sum starts from here. Never do the mistake of writing this. You will be losing mark over there. Okay? So as I was involved with the correction process thoroughly, so I know it very well. X belongs to 0, 1 implies root x belongs to 0, 1. With this step your sum starts. Now sin inverse root x, cos inverse root x, we can write pi by 2 because both are belonging to this interval. So I going to be changed to sin inverse x, and this minus cos inverse x is there. So sin inverse x minus cos inverse x you find from here. This divided by this is equal to pi by 2. Substitute here also. Since no substitution is done, you just write dx. So now separate. I equal to 2 by pi integration 2 sin inverse root x minus pi by 2 dx. Clear? So this will be 4 by pi this minus dx. Clear? How to tackle with this sum? Because sin inverse root x and minus minus plus. Isn't it? Now second part is easy. This one how to do? You have to do it separately. Let I1 equal to sin inverse root x dx. This you can use by parts. Sin inverse root x first, dx integration is x minus derivative of this thing. Sin inverse x derivative is 1 by root 1 minus x square. So 1 by root into root x derivative half x to the power minus half dx. Clear? So just simplify it. X sin inverse root x half 1 by under root x into 1 minus x dx. This is x. How to integrate this one? You can change into standard integral or make a substitution. What substitution? Normally you will prefer it to do it by standard integral, but I will be doing like this. Let 1 minus x equal to z square. You can, this is one alternative method, you must know. So minus dx equal to 2z dz, dx equal to minus 2z dz. Substitute there. Minus 2z dz by x is what? 1 minus z square. This is z only. These two get cancelled. So now the value becoming x plus dz by root 1 minus z square. Okay? dz by root 1 minus z square. So this is changed to x sin inverse x plus sin inverse z. This plus z is what? Root 1 minus x. So here you just substitute what you got there. 4 by pi. Just write the answer now. The answer is 4 by pi, whatever you got, that you put there, x sin inverse x, sin inverse root 1 minus x, this minus x plus c. Clear? Understood? Okay? How to do sum number 20? What substitution you make here? I just remind you, you might have done. Let us do it by the easiest way. 1 minus root x. So the only substitution is put x equal to cos square theta. Why? What is the advantage? That root x will be, x equal to cos square theta. Then root x will be cos theta. 1 minus root x will be 1 minus cos theta, nothing but 2 sin square theta by 2. 1 plus root x 2 cos square theta by 2, and this implies dx equal to 2 cos theta multiplied by minus sin theta into d theta. So this I is changing to under root 2 sin square theta by 2, 2 cos square theta by 2 minus 2 sin theta cos theta into d theta. Clear? Understood? So now we go on simplifying. This will be sin theta by 2 cos theta by 2, and this minus 2 into this sin theta, you write 2 sin theta by 2 cos theta by 2 multiplied by what? Multiplied by cos theta d theta. So cos theta by 2 getting cancelled, strike it out, and it will be minus 2 sin theta into sin theta, 2 sin square theta, 2 sin square theta by 2, which is nothing but 1 minus cos theta, minus 2 cos theta d theta plus 2 cos square theta is, isn't it? So there will be minus 2 sin theta plus theta plus sin 2 theta by 2 plus c. But this is not the answer. Never do the mistake of converting this one in terms of x. Okay? So you have to do it in terms of x here. X is cos square theta. So cos theta is root x. So minus 2 sin theta is root over 1 minus cos square theta, 1 minus x. Theta is cos inverse root x. This is sin theta into cos theta. Root x into 1 minus x plus c. One of you send me the doubt in question number 17 also. Send your doubts, please. I am waiting for your doubt. But you have doubt provided you have solved. No, if you have not done anything, you have no doubt. If you are doubtless, you will be doubtful for me. Okay? So better you send some doubts. Let me check the description box also. If you have sent me there also. You complete the sum by putting what? F of x plus b equal to z. Ordinary substitution. Just put f of x plus b equal to z. Then you check the answer with me finally. Finish it. Make this substitution, put f of x plus b equal to z. A into f dash x plus b dx equal to dz. So f dash x plus b dx equal to dz by a. So this thing changed to z to the power n dz by a. Integrate and replace all the z in terms of f of ax plus b. Do it, finish it first. Just a minute. Complete the sum. Just complete the sum. So there will be 1 by a z to the power n plus 1 by n plus 1 plus c. So 1 by n plus 1 into a, the value of z is f of ax plus b to the power n plus 1 plus c. Clear? Understood? Now go for this sum also. Just quick revision if you have done it before. If you have not done, then also you do it. It is e to the power x, writing in this form to make you understand in the beginning only. 1 plus cos 2x dx. Okay? So this will be e to the power x 2 plus 2 sin x cos x by 2 cos square x dx. Now separate 1 by cos square x divided by cos square x dx. Okay? So actually this is going to take this form, e to the power x into fx plus f dash x. Sec square x plus tan x dx. If we take this one as fx, this part, then this is going to be f dash x. So if the integrand is of this form, e to the power fx plus f dash x, you know its answer is, so here it is going to be e to the power x tan x plus c. Clear? Now go for solving this one also, like 24. You make a substitution x equal to cos theta. This is not so difficult. 24 you do root over x square plus 1 log of, very good manipulation is there, 2 log x by x to the power 4 dx. Okay? Let us do it. root over x square plus 1 log of x square plus 1 by x square, and this thing is x to the power 4 dx. Under root x square plus 1 log 1 plus 1 by x square dx by x to the power 4. Okay. So this will be changed to, now whatever you do, log 1 plus x square you have to reduce. That 1 plus x square, 1 plus 1 by x square, you are going to put z. So its derivative is what? Just look at that. It will be minus 2 by x cube. So take it accordingly. You write x square plus 1 by x will be getting this form. If you take x inside, 1 by x cube log 1 plus 1 by x square dx. Clear? So this implies you take x inside, x square plus 1 by x square 1 by x cube. Okay. So there will be root over into 1 by x cube. Okay. Now put one plus so minus 2 by x cube dx equal to dz. So substitute there root z log z minus dz by 2. Okay. Now keep minus 1 by 2 outside, z to the power half log z dz and then apply by parts. Which one to be taken as first function? Log z. Indication of this is what? Half plus 1 by half plus 1. This minus log z derivative 1 by z, z to the power 3 by 2 by 3 by 2 dz plus c. Isn't it? Log z first function. So minus half, this should be 2/3, this minus 2 by 3 dz plus c. So put the value of z here. Z is minus 2/3 into minus half, it will be plus 1 by 3 z to the power 3 by 2 by 3 by 2. Isn't it? This integration z to the power half plus 1 by half plus 1. Just simplify it, then it will be done. Okay. So these are indefinite integration sums given in miscellaneous exercise. Just one more sum I would like to show you. I would like to remind you, better to say, that is in partial fraction. This is going to be some number. Just before exam, this can help you a lot. Sum number 18. Exercise 7.5 in new book. Probably it is 7.4 or 6.4. Check sum number 18. I am writing the sum here. The book I have, I found this sum. Is better you revise before your board based examinations. This divided by x square plus 3 into x square plus 4 dx. So how to proceed this one? How to start? This you cannot use partial fraction directly, because in the numerator x square is there, denominator also x square is there. So what you will do here, you just replace x square by t. Okay, just replace x square by t. Then I am just writing the integrand. I am not substituting. You should remember t plus 1, t plus 2 by t plus 3, t plus 4. Okay. So again with t, index of t in numerator is t square. Here also t square, highest power. So you have to divide. Then only you can do. So better you split this one as t square plus 3t plus 2 by t square 7t plus 12. Okay. If you write this one as t square 7t plus 12, I mean going to divide, then you have to write minus 4t minus 10, that divide by. So answer is 1 minus 40 plus 10 by. So I going to be what? This is not I, just the partial fraction will do, then we will replace t by x square, then we will integrate. No integration now, just know how to split this one into factors quickly. For this one you do partial fraction. Okay. Now you can replace there also, but I would like to do it there. 40, the second part, this by t plus 3, t plus 4. So this thing changing to a by t plus 3, b by t plus 4. By partial fraction, cross multiply. So 40 plus 10 equal to a into b into t plus 3. Now get a and b from there. Put t equal to minus 3. A into 1, so a minus 2. Put t equal to minus 4 also. So there will be minus 6 equal to b into minus 1. B equal to 6. Clear? So and we got. So 40 plus 10 by a by t plus 3 plus b by t plus 4, isn't it? Minus 2 by t plus 3 then 6 by t plus 4. Clear? Now this part partial fraction is done. We bring x square back because you have replaced, not substituted. You directly write this one x square plus 3. So this one changed to 1 minus, minus minus plus, clear? So now the whole integrand is changed to this form, isn't it? Integrand was this, and that we have changed to this form. So this you write 1 plus 2 by x square plus 3 x square plus 4 dx x, and then what? Dx by x square x square plus 2 square. So this will be x tan inverse x by root 3 6 by 2, and this will be tan inverse x by root 2. Clear? Done? Understood? Now from NCERT exemplar book on indefinite integration, let us select a few sums which may be asked in your school based or board based examinations. Okay, the book I have, from there I found a problem like this: tan to the power 8 into sec to the power 4x. Okay, so how to solve this sum? Make a substitution. Tan x equal to z. There is a manipulation, that's why I have selected this. It is tan to the power 8x, and then write sec to the power 4 as 1 plus tan square x into sec square x, isn't it? Now complete the sum by making a substitution over there. What substitution? Put tan x equal to z. Make a substitution, put tan x equal to z over there. Just simplify and integrate. Finally, do it. So this implies sec square x dx equal to dz. So I equal to z to the power 8 1 plus z square into dz. So just separate, integrate, and then replace z by tan x. It's okay, this was not a difficult sum. Just integrate. and replace z by tan x. Another kind of sum I find here, that is dx by 2 sin square x plus 5 cos square x. How you do this sum in indefinite integration? Think, then I will solve. The book I have, it is sum number 22. Next one I am just writing here. If you have done it, you go for this. Cos 5x cos 4x by one minus cos 2 cos 3x dx. For integration of this one, remember, if the integrand is of this form, a sin square x b cos square x plus c sin x cos x plus d. Maybe one of the ABCD is 0 or two of them 0. Then also the method is you multiply numerator and denominator by sec square x and then put z equal to tan x. So what is the step here? Multiply nr and dr by sec square x. So the integrand changed to what? This divided by sin square by cos square, it will be tan square x plus 5. Now make a substitution, tan x equal to z. Put tan x z. So this implies sec square x dx equal to dz. So there it will be dz by 2z square plus 5. How to finish it? Take 1 by 2 outside. Z square plus root 5 by 2 whole square. You understand? Is it okay? So this will be 1 by a tan inverse x by a root 5 by 2. So it will be, well, just root 2 by 2 is 1 by root 2 and root 10 tan inverse 2 by 5 into z tan x plus c. Clear? Now go for next one. This is brilliant sum. Next one. Cos 5x plus cos 4x by 2 minus cos 3x, this sum. You need to make a substitution over there, but before that you make one sine or one cosine in the denominator. Multiply inner and rear by sine 3x. Why? Because sine c minus sine d we can apply in denominator. So sine 3x, this divided by 2 sine 3x cos 3x, it will be sine 6x. Okay? So there it will be cos c plus cos d we apply, 2 cos c plus d by 2 cos c minus d by 2. Just apply it. And here sin c minus sin d, 2 sin c minus d by 2 cos c plus d by 2. Okay? Clear? So one term strike out from inner and rear. Then in numerator what do you find? There is minus sine 3x by 2 and this is sine 3x. So immediately you change it into the form 2 sine 3x by 2 cos 3x by 2 into this 2 also is strike out. This divided by minus sine 3x by 2 dx. Am I correct? Check once. One of you send me the sum root x square plus 1 log x square plus 1. This one done by me already. I hope you have understood. Okay, it's done. Now let us finish it. Sin 3x getting cancelled. So this will be minus 2 cos a cos b cos a plus b plus cos a minus b dx. Okay. So this you write minus sin 2x by 2. Am I correct? Is this clear? Hope you have understood. Let us go for this problem from exemplar book only. That is, in my book, what I have here, it is number 24. Root x by, it is also a brilliant sum. Why brilliant? It is brilliant to give you trouble, to bring trouble in it. Okay, to think what substitution we have to make. So be ready, be future ready. Put what substitution? You write this as a to the power 3 by 2 whole square x to the power 3 by 2 whole square dx. Do you see something over there? Put x to the power 3 by 2, you take z, t, whatever, but I will take different because I can see another step in forward direction. That is, if I put x to the power 3 by 2 equal to a to the power 3 by 2 sin theta, then my calculation will be easier. Inside root there will be cos square. We can bring it outside, isn't it? So you differentiate with respect to theta. It will be a to the power 3 by 2. So this thing is what? So substitute there 2 by 3 a to the power 3 by 2 cos theta d theta, this by under root this is a to the power 3 by 2 whole square sin square theta. Clear? So you take a to the power 3 by 2 common inside root, so outside it will be a to the power 3 by 2 only. There it will be 1 minus sin square theta, isn't it? So strike the common factor out, so there will be 2 by 3 into theta plus c. Theta is what? So this will be sine inverse. Never forget this step. You must change, isn't it? If you don't change, then you are going to lose marks from here. Okay? Let us take another brilliant sum in the book I have. It is sum number 39. That is e to the power tan inverse x 1 plus x square by 1 plus x square dx. We have to make a substitution here, otherwise you cannot reduce. How to? You put x equal to tan theta. So this implies dx equal to sec square theta d theta, tan inverse x is what? E to the power theta, and here 1 plus tan square by 1 plus tan square. Do you find something over there? Do you see something over there? Whenever e to the power and some function of x is involved, be careful that it is going to be of the form e to the power x fx plus f dash x or not. If it is not of that form, it's a very easy sum. Normally e and a function given means that can be changed to e to the power x fx plus f dash x form. So you write 1 plus tan square theta, you separate sec square theta, tan theta, sec square theta. So easy sum. Looks so difficult. Then it is fx, this is f dash x. So answer you know it very well. So this theta is tan inverse x into x plus c. Clear? Now how to do this one, root 10x dx, and 40 also. In I have this one also, 40 in the book I have. You think both the sum, and then 43, number doesn't matter, these types of sums matter. What substitution you are going to do for these sums? And 42 also. In my book it is 42. Sum is, if you don't practice, then you will suffer a lot. You need to practice, no? Otherwise you cannot finish this kind of sums easily. And here the MCQ is given. Students don't believe, they laugh at us when we say that this kind of manipulations important for all competitive exam, including JEE. They don't believe. They don't have trust on our experience. This manipulation only matters if you learn it properly. In all exam you can apply the concept. Okay, WBJ, JEE main will not be difficult to get a good rank over there. Put x equal to a tan square theta. You must be very fast putting all these. Normally my experience, students do faster than me end of the session, gradually. Okay, this is true for all teachers and all students. So put x equal to a tan square theta, then dx will be what? 2 tan theta sec square theta d theta. So I equal to sine inverse. Why I am making this substitution? First you have to understand this. Why did I take this substitution? This one. Because it will reduce the integral, no other reason. It is a tan square theta, this by a sec square theta, 2a tan theta sec square theta d theta. Clear? Little bit manipulation after this step. Tan square by sec square. You have passed class 10, 11, all these things. This will be sine theta. You can recognize, and I am not ready to explain that step. Sine 2a tan theta sec square theta d theta. Okay? Clear? So this is changed to 2a theta tan theta into sec square theta d theta. What to do after this step? After this step, by parts, we will be taking theta as first and this whole thing as second. Why? This can be integrated easily. So do that. Take theta, the first function, theta into, I am just showing you integration of the second part. If you also do in exam, just show your calculation, you can use the result. Because in the adjacent part of the answer script, you have shown. Don't cancel it, you keep it there. So tan theta into sec square theta d theta, how do we integrate? Put tan theta equal to z. So sec square theta d theta equal to dz. Z dz, it will be z square by 2. Okay, done. So it will be theta into tan square theta by 2 just found minus 1 into, isn't it? So you write this way, theta into tan square theta is what? Sec square theta minus 1 d theta. So this you write a theta tan square theta, a sec square theta is tan theta minus theta plus c. Theta is what? Tan theta is what? We made the substitution. What does this imply? Ideal 5 mark sum. Tan square theta x by a. So tan theta root of x by a. Theta is tan inverse root x by a. If teacher of any board asking this question, method is same. They can ask. It's a very common sum. Root tan x, how to proceed? They have hinted here. They have taken tan x equal to z square. Okay. There is easier method also. If you are ready to excel in integration by using trigo, then follow these steps. Root tan x, you manipulate this way. Root tan x, you will say that, will I memorize? No, this is a technique. I have also learned from someone before. Maybe I have learned myself also. Because in our time, teachers, scarcity of teachers were there. In rural place, basically, no teacher was there to teach. So this will be what? Root tan x I have to get. Root tan x plus root cot x minus, we are writing, or plus root tan x minus root cot x by 2. You can write this. Okay. Now, the integrand also going to be of this form. If you are given this integrand, this will be integration of this thing plus integration of this thing. Clear? So this is going to be root tan x half I have used my past experience to solve this sum. People should have the past experience. People must practice to excel in exam. And why? I am thinking the next step. Just express in sine and cosine. And this one also. We have to ask you question from solve example, miscellaneous, exemplar. Sometimes you convert MCQ to descriptive also, no? To give you trouble. MCQ question, some brilliant sums are there in exemplar book. Convert it to the descriptive one and then you solve. So better my suggestion, before the next session, you solve all the MCQ and indefinite integration sums from exemplar first. Then check whether any sum you don't know in NCERT or not. So next week also I can discuss your doubts this manner. This will be root sin x by root cos x minus I told you I am using my earned experience, whatever. So this will be sin x, take LCM and write this. Clear? Half into sin x by under root Okay, done. Now I can see one thing, this 2 sin x cos x, just let me do it. You are multiplying and dividing by 2. Inside root there will be 2 sin x cos x. That you write in the form 1 minus sin x minus cos x whole square dx plus here also by under root sin x plus cos x whole square minus 1 dx. Put sin x minus cos x z here, then dz by root over 1 minus z square. Put sin x plus cos x z here. Isn't it? You understand now? So this is of the form dz by root 1 minus z square, and this one of the form minus dz by root over, or you take separate variable, dt by t square minus 1. This is sin inverse z 1 by root 2 log of mod of, simplify is yours now. I am not going to do, ending the session here. Just put z equal to sin x minus cos x here and t equal to sin x plus cos x. Clear? Understood? So what I told, you should remember, practice